many good things. We went through static, reviewed static stuff. We went through static variables, static methods. Uh, we talked about pointers. I showed static variables in a utility class called CSTR. We talked about arrays and pointers. We talked about void pointers, R value, L value, and rule of 5. And that's where everything ended, right? Rule of 5 was the last thing we talked about, right? Questions?
Can we review last class again?
Review it? Review the movie you're talking about?
Yes.
Okay. Okay, so I love those type of questions. Any questions? Can we have the last session again? I'll do it. That's okay. I'm not going to go from scratch, but I'm just going to talk about R value and L value, references, and I'm going to end with rule of 5. Okay? So quickly going through, people at home, you guys are okay for me to review the move semantics, going through.
Yes, Professor.
Okay, very good. There's a yes coming over there. So yeah. So again, please use your emojis over there to give me thumbs up, down, and things like that. Okay. So we said that we learned references in OOP345, and we have a new type of reference that's called an R-value reference. And R-value references are essentially a way to detect if the object's reference that is being received is a temporary one or it's one that is about to die. Soon we're going to categorize left value and right value into more pieces, but that's as far as we need to know. And why do we need such a thing? We mentioned that, like I explained that if I want to give you a cup of coffee, there are 2 ways of doing that. Number one, that I'm going to get a cup of coffee. You come, I'll give you the coffee. You get the coffee. You say thank you. You go. I don't have coffee.
Sorry, Professor, to bother you. But then the voice is like not constant. Sometimes it's very low and then it's fine again. Like, I think you should adjust your mic. It will be.
If I want to adjust my mic, I have to jump through the ceiling because the mic is connected to the ceiling. Can you hear me now? Can you hear me now?
Yeah, it's better now.
Okay, wait.
Otherwise, previously it was just
okay,
like
so
fluctuating.
it's possible that I was walking around. I'm going to stand still. I'm going to count to 10. You tell me if it's good, and then I'm going to stay right there, okay?
Okay.
1, 2,
Oh,
3,
sure.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Was it good?
Yeah, it was good. Yeah.
Okay, so here to there. All right. Okay, goody goody. So let's continue. Cold outside, I see. All right. When you see people coming in and they're like Rudolph, you know that it's cold outside because I was in there and I'm like a big red bulb on my. Yeah. Anyways, it's good. It's healthy. All right. So, as I was saying, if I want to bring you a cup of coffee that I desperately need now, I would actually come to you and with a cup of coffee in my hand, I would give you the coffee and you would go. And this action the result of this action is that I will no longer have a coffee and you're going to have a cup of coffee. That's how things work, right? But sadly, that's not what we have done in OOP345. In OOP345, if I wanted to give you a cup of coffee, I would come to you, show my coffee, you would look at my coffee. First, you would build a cup identical to mine. Then you would see how I made my coffee. You would brew a coffee exactly in that manner. You fill your cup to the identical level of my cup of coffee with exact same procedure, and then you would go. I would have my cup of coffee in my hand. You would have your cup of coffee in your hand. But I didn't want a coffee. So I would have thrown away my coffee because I don't need it anymore. That's what we have done. That's called rule of three, which essentially everything is copied when they are passed by value, which we don't want to do. I want to, if I do not need the coffee and I want to come to you and give it to you, it's better for you to take my coffee and I'll go away. You don't waste time building anything because you already have something made. Essentially, I move my coffee from me to you. I move my data from me to you. You're going to take ownership of my coffee. I have ownership of nothing. And that's rule of 5, which essentially, instead of writing a copy constructor, I'm going to write a move constructor. So whenever I find it necessary, I'm going to say move the data from this object to another instead of copying. And that causes the thing. Or if I have two objects, so I come to you, you have your own cup of coffee, I have my cup of coffee. Now assignment wants to happen. So you want to have the exact copy as I do. You don't want your own espresso, you want my lousy Tim Hortons. So what you do, because you already have espresso in your hand, you throw away your espresso because you don't need it anymore, and then I move my Tim Hortons coffee to you. That's assignment. So in assignment, you have to get rid of your own and then take ownership of mine. In copy construction, you don't have anything. You just take ownership of mine. In assignment, you first throw your own away, then you take ownership of mine. And that's move assignment. How this is possible? It's because of our value reference, the 2 ampersands that we add after the name of the type of the variable. When you do that, the compiler can actually identify to call the one that is designed for move. So R value reference, like a regular reference, it is a reference, which means it becomes a new name for an already existing thing. You can change it and do whatever you want to do with it. But the only difference is that it is identifiable. Are we clear on that? So we said, now that we have that facility, which is essentially is recognizing, so essentially when so we identified what is an R value and R value. We said, like, when we have a double like that, this is an R value because it is a temporary double created out of an integer. When I say name out of John, it creates a temporary name out of John. Even when I write Henry over here and I set the name to Henry, because right side I have Henry, left side I have a name, this Henry over here will be upcasted to a name first, which is exactly like line 37, and then it's passed. Therefore, it's a temporary item. And we can recognize those using R value references that are 2 ampersands. So with that which value, I can literally identify which one that is coming in is temporary or not. But that's for automatic stuff. You can always overwrite that. You can literally request that I want to move something. So if something is not temporary, but you still want to remove its properties, you can always put it inside a move. So if you say move this, it means now it becomes an R value. And the other one works too. But we'll come to it later. You can do ref, and it means do not move this. Copy information out of this. So you can literally copy it instead of moving. So we wanted to implement that using, applying it to the name thingy that we had. We said we have a name. Name has a character value, a character data that is dynamic. Okay, that is dynamic, and that dynamic information is the one that is fit for moving. If you don't have resources outside of your scope, moving and copying and these things, they don't make sense because your object contains everything anyway, okay? But if the data is outside, then moving and stuff come to play. So I allocate the information into the M value using the allo copy that I have. And I have an assignment over there that does the same thing, which is essentially, sorry, I have a copy constructor that uses the operator, the copy assignment to actually copy the data. And the copy assignment, where is my copy assignment? It is right over here. Let me bring it up. Is here. Quite frankly, I'm not a big fan. When you are in a test, it's good to reuse your operator equal. When I program for my own, I write functions and I recall functions if I want to not repeat my code. Reusing assignment operator in that one, I don't know. I'd rather actually call the allo copy in there. It looks more elegant too, but your choice. Okay? Just giving you options. 3, 4, 5, I cannot force you to do something. You need to like it to do it. Okay? You have to do it, though, but the way you like it, the way you think it's more efficient. And you have to have some reason behind it. Anyways, so I have the copy assignment and copy constructor. But then, now I want to apply moving. First of all, if you want to so let's do it like this. So what is the difference between moving and copying? The very first thing, when you copy, you don't change the source. When you copy, you don't change the source. Therefore, your copy constructor is always constant reference, right? When you are moving, you are changing the source because you are taking their ownership away. That means the right value reference that you are passing instead of regular reference cannot be constant. And the process is exactly as I mentioned. Was that a question? Yeah. And loud, please. So the again, one more time.
Okay. So in moving, as you said, we cannot have one constant. Is it affect if one is static and one is not static?
No. Static is a completely different ballgame. Static, don't mix the two. It doesn't even apply here. Static is something that is permanent with respect to lifetime of your application. It has nothing to do with
But how we said that if it's the function is not the object of the function is not static, it's one to many, right? Or is it the opposite way I'm saying?
when the object is not. I'm trying to find the relation between static and what you're saying here. Static stuff are things that we want them to stay alive while program is running.
Yes.
Moving is to take things other have so I don't have to recreate it. Now I might kill it afterwards, right away after I use it. It's like I get your coffee, I drink half of it and I throw it away. It's not like I get your coffee. This coffee is going to stay with me forever and ever and is never going to go away. You follow what I'm saying?
A bit, yeah.
Yeah, so moving is, let's put it like that. I'm going to give you a very easy and simple explanation of it. Moving is all about recycling. You want to recycle stuff. You don't want to throw it away. That's all. Okay? So in move constructor that you see that I have over there, that I'm receiving that right value reference at line 29, what I'm doing is, actually that's redundant. I don't know why I'm even doing that. I'm checking the other one to be null or not. Seriously, what are the consequences if it's null? Nothing's going to happen. I'm going to set my own null. There's null. Everything's null. I don't know why I'm doing that. So I'm removing it. It just doesn't matter, really. I'm saying I'm writing an if statement. I don't know which one is more expensive, writing an if statement or just assigning something to another, right? So I'm just going to do that. I'm going to say if the other one is null, then I will become null, and line 31 becomes redundant. But who cares? Just one assignment, right? Not very expensive. Where if statement is condition check, go to, jump. So probably this is quicker. Anyways, so I'm going to say I want to build myself out of the object n. I'm going to say give me object n's data's address and remove their address. Done. It means I own theirs. Done. As simple as that. No copying is needed. Okay? This is exactly the mistake we made in OOP345 when we were copying. And you were losing mark. And we say, oh, you didn't copy. You just, okay? It's that. So, yes, question? No, okay. No, you were just.
No.
Yeah. All right. So that's that. That's about copying. So you take ownership. So you take ownership. I think this is more. So you take ownership of other, right? And remove ownership. And you're done. So you will be owner, and the other one has no access to it. Yes? Loud. Copy and, you're talking about copy and moving at the same time? Because sometimes you want to copy. See, there are two different ways. Sometimes I want your coffee, but sometimes I want the notes you took in class. If I want the notes you took in class, you're not going to give it to me. You want me to copy it, right? It all depends. Sometimes you want to move stuff. Sometimes you want to copy stuff. And based on the logic of your application, now you have the choice. You didn't have it before. Before, we only had to copy. Now we can choose to copy or move. Right? Does that make sense? You don't look satisfied. Doesn't you? Smile. There we go. That's better. Too serious. I'm like, oh. Okay. Well, so we're okay, right? We're okay. All right. Okay, so that's that. And this is just reusing the assignment operator like the other, which we're going to come back to. And in assignment, you do everything that you are doing. So in move assignment, as we see over here, I am receiving an R value reference of the other. No. Sorry, I thought it's smart enough to know that I'm about to check, but. Yeah. So now I have something. I exist. It's not that I'm making something. I exist. And because I exist, I have data. Assignment is when two objects already exist. In construction, the object doesn't exist. It wants to build its information based on another object. Therefore, you don't need to worry about the current information. In assignment, other object exists. Now that the other object exists, first I have to see if the programmer using this is crazy or not, which means assigning something to itself. We make sure that that doesn't happen. Okay? That's number one. Number two, after checking that this is not a self-assignment, then I'm going to get rid of my own, which is deleting the m value. So I'm getting rid of the current information. Remove current data. Then we take ownership of others' data. Then we remove ownership of others. Okay? So remove is wrong. I'm going to say delete current data. Take ownership of others' data. then remove ownership of other. And then we're good. Yes?
So how you said that in move constructor we don't have to make sure if it's a null pointer, right?
Mm-hmm.
In the if condition, does the same goes for the copy constructor? Like how we check in that also if the
No, in copy constructor, you are doing copying.
okay.
You need to know if the data exists or not.
But same goes for move then, right?
No.
We are gonna
Move is just one assignment. Okay, move. Let's see if I can do something here. Give me a second. I want to try something. Okay, so let me see if I can. Problem is that I cannot. Let me just use this. I wanted to use the one that we have up there, but I think this will do too. I wanted to use the fancy thingy up there, but I think this will okay too. So moving. When I move, this is my data, right? I do this. First, I find this in there. This is the data that I want to move. This is what I have. Okay? Now, you're saying, I want to check to see if it's fair. This is not null, right? So this is not null. All I need to do is to do this, take ownership, and remove the ownership of the other. Right? That's moving, correct? So why don't I want to check for null? This is why. Let's say the other one doesn't have anything, right? Right? Then what I'm going to do, I'm just going to say, and I want to move, I'm going to say copy the address from here to here, so this becomes this one too. So no moving is needed. No, I didn't do anything, right? Now let's do copying, okay? Now, okay? I'm not checking for null. I'm just copying, right? So I'm going to go over here, see what is the size. I'm going to put the exact same size, bring everything to here, right? And then point. Copying done. I didn't check for any null, right? Now I want to do copying. I'm not checking for any null. I want to go pick up the data. No data, crash.
Okay.
You follow what the difference is now? Yeah. In here, I have data that I have to copy. Over there, I'm just pointing to different places. That's why I don't need to check for null. Okay? People, markers, good for your health. Remember I told you, I just mentioned it today to my OOP345 class. For some reason, 244 and 345 looks like the same subject that I'm teaching, but one is just fancier than the other one. But anyways, remember I told you last semester, go get one of those 4-colored pens, and anything with dynamic memory allocation that you're doing, draw it on a paper to understand it. Really, if you don't have it, go do it, especially now. Okay? Because this is really important. Anything that you want to see what happens about it, draw it. See if in your drawing you hit the wall. If you hit the wall, your program's going to crash. As easy as that. Are we good? All right. Okay. So now, yeah. So that's now. The only thing that you need to worry about when you are reusing your code is that when you have the name coming in as an R value reference, the compiler might not recognize that that's a reference to be moved. So you have to explicitly mention to move it, to make sure that move is going to get called, not copy by mistake. All right? As easy as that. All right? And destruction is destruction. So that's essentially the gist of rule of 5. You happy? All right. People, everything's okay at home. There we go. Thumbs up. There we go. Thank you, thank you, thank you. All right, 2 people are good. The rest are very in a bad situation. Now people are coming. Good. Yeah, okay. All right. All those people who give me thumbs up at home, give me a minute to digest it, okay? Because they give a thumb up and immediately turn it off. I don't see. So when you give me a thumb up, let me give you an okay, and then you remove it so I can actually see you are doing it. Okay? Next time, not now. Okay. Now you can remove it. All right. So that's that. So that was moving. Anything else before I continue? No? All right. So let me just copy this. I'm not going to save it.
Excuse me, Professor.
Yes, go ahead.
I have a question. So it's like, what are the common mistakes that we are usually make when we try to, implementing the rules of 5? And
May I
like,
ask you to
how
please,
can we avoid them?
can I ask you for a favor, please? You're in a public place. Could you please get
Yeah.
as close as you can to your microphone so it kind of dampens the other sound? Be close to microphone when you're asking. Go ahead.
Okay. Hello.
One more time. Go ahead.
Can you hear me now?
Yes, go ahead.
Okay, I want to ask like, what are the common mistakes that we usually make when we try to implementing like rules of 5, and like how can we avoid them?
Common mistakes. Common mistake. The only thing that I can just point at is not forgetting to do move when you are reusing your code. The rest is very straightforward. Actually, the move constructor and move assignment are very, very simple tasks. They are very simple tasks. So if it was rule of 3, then I could go on and on and on. But for rule of 5, for moving, the only thing that I see when you are reusing, make sure that you explicitly mention that you want to move. Other than that, there is no mistake. The logic is very clear. Okay? All right. So no, I need to bring C string over here too. Give me a second. Let me bring it from the last thing. Add existing item. Okay, so another common mistake is not to put virtual for the destructor, which happens for rule of 3 too. So this is one of the biggest problems, like having what happened? One of the biggest problems that we have, people forget to make their destructors virtual. And that causes lots of problem with memory leak. Lots and lots of problem. So when I tell you always make your destructors virtual, always, it's not a suggestion. Really do that. That saves you lots of time in debugging your code. Always make your destructors virtual, no matter what. You're writing it. Simplest thing, you have a destructor. First of all, 2 things. First, have a destructor. Always have a destructor. Number 2, even if it's not a dynamic thing, have a destructor. And number 2, make it virtual. So when you create a class, this should be your habit. So I want to create a class, so I'm going to go include IO stream using So when you want to create a class for, give me a thing, class for what? Give me something else, somebody. Class? Person? Okay, class person. Immediately you go public, virtual, not like that, person, default. Immediately do that. And then start thinking. If you have to create a destructor for this later, you can remove that. But always create your destructor no matter what. Because if in future you inherit something out of this class and you don't have a virtual destructor, you will have memory leak. I guarantee that. Okay? Remember, always create a destructor, have a destructor, and make sure it's virtual. So you ask for common mistakes. That's a common mistake. All right? Always have a destructor and make it virtual. You can change it later if you need. Okay, so I'm going to actually put it as a separate thing over here. I'm going to call it B. Always have a destructor. Are we good? Okay? All right. So initializations. We have talked about this in OOP345NBB, but I'm going to mention it over here again. Aggregate initialization is something that you should use in C++ from now on. So whenever you want to initialize something, open a curly bracket in front of it and put the value in it. That's the easiest syntax. You can put this assignment in front of it, not to put assignment in front. It doesn't make any difference. So anything can be initialized using curly brackets. Okay? So if you want to set something to 0, open curly bracket, close curly bracket, let it be. It's going to set it to 0. If you want the default constructor to be called, same. If you want to set a value to it, you can just put value inside that curly bracket. If it's an array, separate the values. If it's a structure, separate it with commas. Yes?
So I don't know how to fix it, but in my code, studio code, it doesn't allow me to do that. It gives me error when I do this. When I do the...
Like with Visual Studio version 1? How?
No, I don't know why, but it does actually.
Okay, sure. Later on. Yes, not after the class. Book an appointment and share it with me.
Okay, sure.
What was that thing?
No.
No, booking appointment is difficult. I said, book an appointment. He says, book an appointment.
Yeah, I will.
Because like that, I can take over your computer and do something with it.
Sure.
Okay. So yeah, so book an appointment. And I'm really shocked when you're.
Yeah.
What is it? Is it 2022?
But I don't know why it does that.
Now I'm going to make your face. But sure. All right. We'll see. Okay, I'll take a look at it. Anyways, so we're clear on that, right? You can put that. So this could be like that. It's the same. It doesn't make any difference. But remember, this is initialization. I see common mistake. People do this. Integer A, then say A. That doesn't do it. It's initialization, okay? Initialization. Explain to me, what is initialization?
Initialization is when you declare the variable and
Seriously? Taking that long? Give it to the lady beside you. Initialization. Oh my God, you don't know this. If somebody doesn't answer this properly today, I'll be mad. Okay.
It's declaring a variable and giving it a value.
Declaring a variable and giving it a value. That's beautiful. That's not the way I say it, but fantastic. Yeah, good. So I don't need to go. So essentially, assignment at the moment of creation is initialization. Remember that. Assignment at the moment, write that 50 times on a paper and bring it to me next day. Have you seen Bart Simpson at the end of all episodes writing the thing? I will not. Okay. So assignment is initialization is assignment at the moment of creation. That's the only time you can use these curly brackets to initialize something. A new type of loop. Now you can loop. Why is it giving me error for cout? Because it's I stream. I'm supposed to have IO stream. Okay, there you go. So a new way of loop, okay, range-based loop. So what you can do, you can write a for loop, okay? And in for loop, at the first thing, you create a reference, you put a column, and then you put a collection at the other side. Why am I not calling it an array and call it collection? Because soon we're going to see that we have a huge variety of repetitive containers, many different one of them. An array is only one of them. And you can actually use it for all these things. So how does it work? Every single loop that happens, EL becomes the reference for the element of that loop. So it becomes the reference for the first element, the next one reference of the second, reference of until it gets to the end. There is no counter in here. EL literally becomes each element of the loop as it goes through it. We okay with this? And why am I actually showing the address over here? I have no idea. Oh, because I don't know. I don't know. Somebody probably asked something and I did that. I have no idea why I did that. And this is one of the parts that auto becomes very useful. Sometimes the types that you have in your arrays are ginormous, like unsigned long int, okay? Instead of writing the whole damn thing over there for this, you can simply say auto reference A. So what happens, that becomes automatically a reference of whatever the type of the element of the array is. So remember, if I do this over here, oops. You will see that pardon me? What is it? Give me line number. No, A is the name of the array. E is the reference to each element of the array. Does that make sense? Yeah, sorry. So let me repeat it, okay? When this loop is happening, EL becomes element of A0 in the first loop. EL becomes reference of A1, A2, and it keeps going like that. And because it's a reference, when you add it, that's going to happen. Now, let me do something else in here. Instead of that, I'm going to do this. I'm going to remove that. Oh, I was showing the address and the element. That's why. Now I know what I did. So this is what I'm going to do. I'll tell you why. Give me 2 seconds. Let me finish it. Okay, so having this now, it shows exactly what is what. Okay, so, all right, are we okay down to this point? Are we okay? Now let me do one more thing. See what happened? At line 15, I made auto-reference E. Sorry, at line 12, at line 10, I made auto-reference E of the elements of array A. And as I was going, I added 1 to those references. When I reprinted, everything is 1 more. You okay? Now take a look at the line 20. At line 20, I do auto E, no reference. What does it mean? It means E actually becomes a copy of each element, not its reference anymore. You follow? And therefore, when I add 1 to the element in the array, it's not actually adding to the element, it's adding to the copy. That's why in line 25, when I repeat them, the exact same elements are there. That's an amazing question to see how close you look at walkthroughs when you're actually walking through them. That's a perfect question, to write that and see if you recognize that the values are not changed. Are we okay?
Yeah, it's just I have to like go through it a little more.
All right, all right. Everybody's okay? People at home, show me those thumbs ups, please. If we are okay with range-based loops. Oh, I'll see you. Askan, are you with us? Askan? Yes, okay.
So using the same auto, can we go 60, 50, 40, 30?
Backwards? Yeah. No. It's a range-based. It starts from the beginning, goes to the end. Okay. You can't do that. No problem. You can't go backwards. For that, we have regular loop. You have to. Are we okay, everyone? Yeah, that was pointers. It was low-level C. It has nothing with C++. No, no, no. This is C++. This doesn't exist in C, people. This is a C++ thing. It has nothing to do with C language. It's pure C++. Actually, I won't be surprised if they haven't had it added to C, but no, we don't have references in C. What are you talking about? No, no, it's not in C. Anyways. Okay. Again, and it works. Later on, we're going to see any content. Oh, something extremely important before we continue. You can't do this. You can't do this because that array is not array anymore. It's just a pointer. Remember that. When arrays are passed to a function, they are not arrays anymore. The size is not known anymore. If you are using it in an array, it has to be in the same scope. If you pass the array to a function, then it's just a pointer. It doesn't know what is its size. So it cannot do arrangement. So range-based loops only happen for arrays. I didn't say for other collections. For arrays, they only and only work in the same scope. You cannot do it. I'm not going to say it's not an array, it's just a pointer. And not an array. Next thing, we are going to talk about nameless structures. So sometimes, say you want to create a class for a student, and you want the student to have a name. But you don't want to create a class name because you are not going to use it anywhere else. You just want the student to have a name and a first and a last. You want to package it in one thing. You can create a nameless structure like that. So essentially, you are saying struct, there is no name, first and last, and you instantiate it after that called mname. So mname is of type whatever that is, and it's first and a last. Now, do you think we can create an instance of type name? So let's say I am in here, I don't know, and I want to create an instance that copies name and then do something so the name doesn't change. Can I do it?
Professor, the mname written outside the struct is the instance of student
Exactly.
class?
It's the instance of the structure. So let's say over here I have double GPA, GPA. Then in here I have integer semester, and so on and so forth. So now in here I can say mGPA is set to 4.0. M semester is, I don't know, semester 3. And mute yourself, please, Muskan. Thank you. And what do I want to say? And I'm going to say mname. The first is Jack, and mname, the last is Black. Okay? Are we okay with this? Now, can I create a copy of mname in another variable? And if yes, how? No. I want to create a variable called, I don't know, temp name, and I want to set that to mname. How do I do that? Because this doesn't have a name. The struct doesn't have a name. It's a nameless structure.
Don't you just write it just beside in format?
Huh? Yeah, now I want it to be in foo. Yeah, I can put comma. Smart guy. He's telling me, can we just do this? Yes, you can, but I don't want it there. I don't want to be a member. I want it to be in a foo. How can I make a copy of name in another one? No. Oh, repeat the same thing again. No, I don't want to. Seriously, people? What did you say? Give it a name. Shame on you. Auto is for these type of scenarios. where you want to make a copy out of it and you don't have a name. What am I going to do? I'm going to do auto. Are we okay with this? We understand now what auto is for? All right. Okay. How to create a copy of a nameless struct. All right. Okay, so let's say I have over here address. Now, the address that I have, it has string street address, right? What else do we have? String city, string country, okay? Now, I want to have a postal code for this. But US uses zip code, and we use postal code, right? String, I want to make it a little bit low level. So instead of string, I'm going to create an array over here. So I'm going to say character, say 21. Because it's low level, I'm not going to do that. I'm going to say cd 21. Forget about a country thingy. I just want to get, okay? So now if I want to write something like this, okay, and let's say I'm short in memory, okay? I want to use zip code. A zip code is an integer number, right? Because it's just digits. Postal code is 6 characters, right? Now, I can put a zip and I can put a postal code, but then I have to choose one. So one of them is going to go to waste. Definitely. It's impossible to use them both, correct? I wish I could have some kind of a construct that I could tell to the compiler to look at this area of memory in 2 different ways. Look at it as an integer and a character at the same time. So when I refer to it as a character, make it an array of 6 characters. When I look at it as an integer, use the first 4 bytes and give me an integer. Of course, if I put something in an integer, the array of characters will be destroyed. If I put something in the array of characters, the integer will be gone. But I will never do that. It is impossible for me to have a zip code and a postal code at the same time. We have such construct. We call that a union. A union in C language, not C++, is the exact same thing. I can say union, say over here, zip code, I'm going to call it. And in this zip code, I can put over here integer zip or character code 6. Now in here, I can say zip code ZC. So now this ZC of mine has both things. So let me call this, make this capital. Not that. This one. Okay? So So in here, if I say, for example, zip code A dot code, if I do that, then I can say, I don't know, did we talk about void pointers and stuff? We did, right? Yeah, we wrote a mem copy, so you know what a mem copy is. So I can do something like mem copy into a.code. Something like that. In 6. That will completely destroy the integer. Or I can simply say a.zip is equal to 1, 2, 3, 4, 5, 6. But remember, they cannot be used at the same time. If you use one, you destroy the other one. Are we OK with this? Are we OK? Just to show you what I mean, like I literally mean that, I'm going to say C out in here, not there. I'm going to say C out in here, address of A dot. So reinterpret cast to, what do I do? Reinterpret cast to unsigned long address of A dot code 0. Why is it giving? Oh, because I don't have. And in here, I'm going to say address of zip. And if I print this, we'll see that they are exactly in the same address of memory, which means they are allocating the same place. OK? That's a union. And unions, like other stuff, they can be nameless too. Union is like a structure. You can, for that address thing, yeah, I could have created a nameless thing. So instead of writing zip code, I could have brought this, you said union that, and just wrote zip code over there. You know what I mean? I could have done that. Questions? Yeah. Yeah, I could have done this. So let me do 2. OK, so in here, I'm going to say union, EF, union. So now, I could have done this instead, because you notice that I didn't know what to call it. So in here, I'm going to call it zip code. So it's only one instance of it, and it puts it in the same place. Exactly like a structure, I can make it a nameless. And it works the exact same way. So if I make this a structure, so it actually occupies, so I don't have to put public schmublic, it applies the exact same way. So if I say over here address A, I can say A dot zip code dot code. In here, I can say A dot zip code dot zip, and it will do the same thing, same place in memory. Are we OK? All right, what else? Did we talk about the, yeah, so Union. Okay, another thing. Stop. Yes. One more time? Mm-hmm. Yes. The other one is gone. Yeah. So to initialize them, the best way to do is this. It wipes everything up in both of them. So they both get initialized. You can't initialize them, but initialize one of them. Yeah, it doesn't make sense. You're right. So if I initialize only zip, then the first 4 bytes of code will be initialized, but the other 2 won't. Will have garbage in it. So it's better to do it like this. So it literally sets everything to null. That's the best way. Okay? All right. Yes.
So how does it do the memory alignment union? Because one is going to be an integer, one is going to be a string.
Why do you care? It does it, right? And if you want to know what the alignment is, do alignof. That's why we have alignof. That's why we have sizeof. First of all, sizeof will be sizeof the biggest one. So essentially, if that can be aligned to 6 bytes, if that, which will not because it's an integer, probably that's going to be 8 bytes. If I check the size of that union, probably it's going to be 8 bytes. Because if you want to create an array of union, 2 integers, the second one has to be divisible by 4. 90%, I'm going to say that's going to be size of a dot zip code. I think it's going to be 8. And I think alignment is going to be 4, actually. So the size is 8. And alignof, I think it's going to be 4. What the hell? What's going on? Did I do something wrong? What does it say? Syntax error after. Oh, alignof, so alignof doesn't work with, ah. Eh? Okay, let me try something else. I'm just trying something because I really don't know why that happened. Okay. So I changed it to a type. Yeah, that was the reason. And alignof is 4. You see that? So I don't know what to say. We okay? Yeah. Okay. Alignof. Union. Align and size. Sometimes this happens in a class where it goes in like downhill in questions, which is very fine. So I'm standing on one thing that I want to go to next, but okay, can I go to the next one now? All right, thank you. So we okay with this concept, right? Are we okay with this? Now, if I go P++ and I print target of P, what's going to get printed in here? Walk through for your quiz? Pardon me? 20. 20 is going to get printed because I went one further, right? Are we okay with this? I want to do this. What do I do? What do I write for a function? Yeah. To advance P by 1. Can I do this? Is this okay? Pardon me? Oh, you mean put a reference. So if I do this, we know nothing's going to happen. The reason is that, again, I told you everything is going to be, it's exactly like OOP345. Nothing in C language is passed by address. That's the wrong terminology. They told you this is passed by value, this is passed by address. In C and C++ language, nothing is passed by address. Everything is passed by value. That value can happen to be an address. You can pass an address by value, which we do. If I said over here, target of P, and I said over here, target of P again, if I do something like this, what I'm going to have, okay, and let me actually have something that prints the array. And don't tell me I need to pass the size. I'm just going to go 5. So if I do this, you will see that it actually changes 20 and 30 to 200 and 300 because I set the target and I set the target. But P itself is not changed. It remains the second one. Does that make sense to everyone? Does that make sense to everyone? Are we good? But if I did this, as the gentleman said over there, now I am passing reference of the pointer to the go next. Therefore, P becomes a new name for P in main, and the change actually takes effect. Therefore, the second one's going to be 300. Moves. Are we okay with this? Are we okay with this? Now, let's say you are in IPC 144. So this is the C++ version of it. How can I make this go next? So this is if you wanted to change the value of a variable in C language, what did you pass to the array, to the function? You passed the address, right? And we said that pointer is just a variable, right? So I can pass its address to, not that, address, correct? So I'm passing the address of P in here, right? When you ask the pass the address of a variable to a function, what do you receive over there? Pointer of that type, correct? What is the type of P in main? Say it. What is the type of P in main? People at home.
Integer pointer.
Integer point. Who said that? Oh, thank you. Okay. So I saw it. So if the type of the type of P in main is integer pointer, and I want to create a pointer to that in Go Next, what the type is going to be? Integer pointer, pointer. And now I can pass the address to it. And now I can advance it. Nope, not that. I changed the wrong file again. Copy. Paste. Now it actually advances, you see? So anything that we teach you in C language, you can draw conclusions out of it and apply it to itself. Anything. When I tell you you can create a pointer to a type, that type could be a pointer to a pointer. What if I want to change P in here? If I want to change P in here, what do? So if I want change, why is it so big? Change P. What should I pass over here? Integer, pointer, pointer, pointer. P. And I'm going to say target of P plus equal 2. I can do that. What if I want to change this over here? Then I will have integer pointer, 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 P. And target of P plus plus. They are all the same. They don't make any difference. You have a variable. It has a type. You make a pointer to that type. The fact that there are 4 asterisks over there, don't go, no, nothing happened. When you do that, you just know the type that you have in the other function is integer pointer, pointer, pointer. You okay? That never happens. Like, no idiot creates something like that. But based on syntax, oh, I came over here again. Based on syntax, that should be okay. So pointer to pointer. Because of this fact, the real, so that's ij ptr to ptr to ptr etc. Okay? Now, because of that fact, you will see that the syntax of main that we mentioned is often referred to as such. Though people don't put square brackets afterwards because it's the same. Right? When you put square bracket, you're essentially creating a pointer to a pointer. That's the syntax for it. It's the same thing. Don't be afraid. When you say character pointer ARG and square bracket, essentially you mean that's a pointer, right? That's a pointer to pointer, which is, this is the other one. Are we okay? Are we okay? 1, 2. All right. Next. What's the time? 2:52. The class ends in like, I want to give you a break, but if I give you a break, nobody's going to come back. So, so let's finish the thing and then we continue. Okay, let's see what is the next thing. Okay, so the JK main signature with PTR to PTR. Another use of let's first talk about I'll bring that one later. It's to start it, I have to talk for 5 hours. I don't want to do that, so I'm going to do this one instead. Give me a second. Where is it? One, two. Copy. So consider this your break, because I'm preparing stuff. Stretch and get ready. Almost done. Almost done. Almost done. Okay, so let's say I have an interface. Anybody remember what an interface was? An interface was an abstract-based class that only had pure virtual methods, with nothing else. Okay? Obviously, we add our destructors anyway, so that's why we have the destructor over there. So I have a shape. Shape is supposed to my abstraction of a shape is something that has an area, and it can be compared with another shape to see if they are the same or not. And also, we can display a shape. Okay? Now, obviously, those are all pure virtual methods, but I can even use that pure virtual method to implement the extraction, the insertion operator for OStream for everyone. So my shape.cpp says anybody wants to print the shape, call its display. Because I have a pure virtual method, therefore it's got to be implemented for all children of shape. Are we okay down to this point? Okay. Now I have a circle, let's say. Okay. So the circle of mine over here implements everything that we have, and it displays. So life is beautiful. It comes to circle. When I come to circle, what does it do? It says a circle has a radius, obviously. It has, so when I look at the circle, it has a radius, and it implements everything. So it sets the radius. And when I say area, it multiplies pi by radius by radius. And to check to see if circle is the same thing as another shape, first I have to make sure that they're both circles. Because if it's a circle and a square, then I cannot check them, right? So I do an opcast. We learned it's OOP345. I'll do an opcast, dynamic cast to a circle, the shape that is coming in. If it's successful, I get a pointer to it. If it's not successful, that pointer will be null. So if the pointer is null, it means I'm done. They're not the same. If it is not null, now I can actually check the absolute value between the difference between the two radiuses, and if it's below the threshold of my range of difference, then they're the same. Because they are doubles, I cannot check for equality. I have to see what the difference is. Remember that, right? An absolute thing is in C math. Or I could have written this minus this greater than minus that value and less than, but I didn't want to, so I just used that absolute value. If you don't know what absolute value is, go home and ask ChatGPT. All right, are we okay down to this point? Now I want to do the same thing for the square. So for the square, I have the same thing, so I'm setting the side. The area is just multiplication of the two sides of the square. And the operator does the exact same thing. Opcast, if it's square, if you're fine. If the difference between the two is less than certain value, they're the same, and it prints it out, and life is beautiful. Are we okay down to this point? Questions? So this was essentially virtual, what do we call this thing? Polymorphism? We call this inclusion polymorphism, right? That was inclusion polymorphism. Now, if I go to main over here, I can display the shape. So first of all, I'll check if it's null. I'm going to say it's null. Otherwise, I'm going to print the shape. This is going to print the shape. It doesn't matter which one it is. It's going to pass the reference of the shape to whatever is that's supposed to print it. And it's going to pick up the proper version of the display, hence the polymorphism of it. OK? Make shape is a function over here that creates a shape for me based on user's need. So I'm telling the user, tell me what is the circle. You want a circle or you want a shape or you want a square? And if the person says I want a square, I'm going to see what the length is, side length is. I'm going to make a square and put it in a shape pointer. If they want a circle, I'll do the same thing, and I'll again hold it in the same pointer because they're both shapes, right? And I return that object back. So when make shape is returning, no one knows if it's a circle or a square. Correct? Good. So I can display it. I can check to see if they are the same or not, and I'm going to delete them and be gone with it, right? My question is this. What happens if for any reason how can I copy the damn thing? New what? Circle or? I cannot say new shape. Shape in abstract is an abstract, it's an interface. How do I do that? It's impossible. How? Huh? Beautiful. He says auto. Can I say auto? No, it doesn't know it. Auto knows it's a shape, and shape is an abstract thing. It says I cannot create it. Validate the shape. What do you mean? How do you validate? We can, you're right. There is a way, but there's an easy way too. There is a design way and there is a way. There is a way is to use dynamic cast. Upcast it to a square. If it was successful, create a new square. If it wasn't successful, create a circle, right? So we are fine, and we copied. What if shape has 900 descendants? I have polygon, I have oval, I have rectangle, I have a triangle. Then what do? I have to keep writing switch statements for 3 years, right? The solution is something like a standard that we follow, like we do. We say, rule of 5, you do and this and that. Whenever you are creating an abstract-based method, abstract-based class, it is customary to, for future needs of copying, to add a method called clone in it. If you do that, you can use the exact same inclusion polymorphism to make a copy out of it easily. So what I can do now, I can actually come in the circle and bring the exact same thing. Where's my... and create a clone over there. Obviously not that. So all I need to do, and the code for it is essentially same for all of them. What do? I'm going to say return new circle, because now I know it's a circle, right? Circle from me. I can call the copy constructor over there, right? Easy. And then I'll do the exact same thing in the square. Now, all you need to do is that, and you're done. The proper version of clone will be called, therefore it's going to be cloned to the proper. So remember, clone is something that you find in many standard classes that we have in C++. Always, whenever you want to copy something and you are not sure what you want to do, check to see if there is a clone. It's very possible that there is one. Okay? Done? Questions? Suggestions? So we have a main over here for it. I'm going to bring that up. That I actually use the clone. So there you go. So now you see over here, I'm actually cloning. So I'm going to say that's clone of S1. And you can actually compare with the clones and everything. So it's just a test for all the, walk through it and see how it works. It's very simple. Let me just make sure it works. It's not going to give me a compiler. OK, it works. I'm not going to test it. You know it. OK. So that's that one. KL, clone main. No, main? Yeah, clone main. That's that one. And the final thing that I wanted to mention over here would be, another very useful thing for auto. I showed you how auto, like you can just copy a nameless thingy. Now sometimes you want to create classes. These classes are utility classes that you want them to do certain things. Like I used to write this class called tracer to be able to trace through things, debugging, okay, and be able to activate and deactivate the tracer program. So what I wanted to do over here, I created a class tracer. So actually, I created a class like that, and I called it tracer. An anonymous class, because I don't want to create. Tracer is like cout. It's only one instance of it. I do not want it to do anything extra for me. And what I did over there, I created this Boolean flag, and if the flag was set to true, I would print stuff out of it. Now, I wanted to actually write things. So to print stuff out exactly like cout. So I want to write something like this. I want to write an operator that prints a message. And I want to write an operator that prints an integer value. So if I want to see what is the value of an integer thing, what do I do? The problem is that because you want it to have cascade, you have to return this. You want to return this, you don't know what is the name of the class. And that's, again, when you can use auto. So so my class got shaped like this. You see? So I could print messages and go through everything and print values if I wanted to. So for anything that I wanted to, I simply added a method to it. And then in my program, I could actually trace stuff and then turn them off if not needed. And because they're all the same object, when I remove the class, they are flagged. You can remove everything very quickly from your source code. It's not going to be embedded in your code with standard stuff. So now, if I set the trace to true, I can actually show messages in it exactly like seen and cout, back to back. And turn it off if I want to, so it turns off and I see if the program runs properly or not. Okay? That's another use of auto. And now I hope you understand what in OOP345 I said. I don't know why we are actually bringing auto in OOP345, because there's absolutely no use for it over there. But over here, for every single thing, you need it. Otherwise, you can't implement anything. There are things that you really, without auto, you can't actually do anything about. 309, 30310, we have 5 minutes. And I need to kickstart templates. I'll let you know. Study as if you have quiz next day you are coming in. Huh? What do you mean by everything? No, I'm just going to ask about auto. We're going to have a quiz about auto. That's it. Now, I'm joking. I'm joking, people, please. Okay. What do you mean, oh, like a quiz? No. It wasn't. No. If there's going to be a quiz, like, and in when is your lab? Monday? Tuesday. So if tomorrow I'll tell you what the question is, it means you have a quiz. I have to do the other class too and see how they do, because there are 2 of you. And if I see everything goes well, tomorrow I post the question. I'm going to say, this is going to be your question. 99% is going to be rule of 5. I'll give you something about rule of 5 and ask you to give you a class with, I'm going to give you a class with some attributes that they are dynamic, and then ask you to write the rule of 5 for it. 99% that's going to be the question. And again, no references. And I'll put a demo test for you to test, and for those who are not my students, to see how you have to open my apps, bring up Notepad++, do your things, and I'll demonstrate in a video so you can see. Questions? Oh. Suggestions? Objections? People at home, are we okay? Show me some thumbs up and down and stuff. Are we good? All right. Thank you. Have yourself a wonderful, beautiful, marvelous weekend. Hopefully we'll
Professor, can I know when is the first assignment
Pardon me?
due? Because there is nothing. Can I please know when is the first assignment
whatever you
due?
believe the due date. Is the due date there? Yeah, but somebody tested it over here. The due date is there. You have to do -do.
Oh, I don't find that command over there.
You don't know that command?
That's
Okay,
oh, I'll see that.
just
No,
listen. Just type submit with nothing after. It shows you help. The help shows you how to get due date.
Okay.
Okay? So
Thank
just
you.
type the submit command for that thing. So just type submit, and it shows you the thing. So essentially, you have to put a -do at the end of the submit command. All right?
Yep.
Have a beautiful day, everyone.